Hi all, today we are going to discuss on the topic Hill Cipher. Hill Cipher is one such algorithm which is used in information security in order to encrypt and decrypt messages. So before entering into the actual concept of Hill Cipher, we should know the concept of finding multiplicative inverse. We know that finding 5 mod 10 is easier, right? Because 5 is less than 10, hence we have written the remainder as 5. And if it is 7 mod 3, we simply divide 7 by 3, which is 3 2s are 6 and remainder is 1. So this becomes 1. So these are easier cases, right? So these are much easier compared to the case that I give now. What is 27 inverse mod 10? This is quite strange, right? So in order to find the solution for this cases, we need something called as Euclid's and extended Euclid's algorithm. So to find the solution for this, let me take it as 101. So to find the solution for this, we have to use Euclid's and extended Euclid's algorithm. So the algorithms used are Euclidean and extended Euclidean. Okay, why do we use these both algorithms? Here, this Euclidean algorithm is used to find the GCD, and this extended Euclidean algorithm is used to find the multiplicative inverse. All we have to do is first check whether the GCD is equal to 1. If the GCD is 1, only then we'll proceed further to find the multiplicative inverse, which means if the GCD is equal to 1, the multiplicative inverse exists for this particular case. Else, no such multiplicative inverse exists for this particular given case. So, the algorithm goes like this. So, I have to find the inverse of 27 mod 101. And the Euclidean algorithm is as follows. So, first we have to write the quotient and then A, B, R. This is how we represent it, where A is the greatest number. So just take these two numbers, which is the greatest, 101. So 101 goes to A. So A holds the greatest value and automatically B comes here. Now just divide 101 by 27. The quotient will be something around 3 and the remainder will be 20, right? So I'll tell you a simple trick in calculator, in scientific calculator, how to do that. In scientific calculators, it's quite simple and easy to find the quotient and remainder. So here I just need to divide 101 by 27. So 101 divided by 27. So the quotient is 3. So it's very easy to write down the quotient. But how to find the remainder? It's very simple. So the quotient is 3, right? So I have to subtract this by 3. I get something around 0.740 and so on. Now I have to multiply this with the mod value. Here the mod value is nothing but 27. So this was the one which divided 101, right? So I have to multiply this with 27. So the remainder is nothing but 20. So that's what I have written here. Similarly, I have to perform the same for all the numbers, which means now we'll be performing some shifting. A will hold the value of B. B will hold the value of R. So A becomes 27 and B becomes 20. Now again 27 divided by 20. The quotient is 1 and the remainder is, since the quotient is 1, I have to subtract 1 and then multiply it with the mod value, that is 20. So the remainder is 7. I have to perform until I get the A value as 1. That denotes that the GCD is 1. So this is 20, this is 7. So just perform the same thing using the calculator. So I get the quotient 2 and remainder 6. This is 7, 6, 6 ones are 6, remainder is 1, 6, 1, 1 6 are 6, remainder 0, 1, 0. Finally I got something like this, which means the GCD is equal to 1. So therefore GCD is 1, that is multiplicative inverse exists. Okay, so this is all about Euclid's algorithm. Now I have to use extended Euclid's algorithm in order to find the multiplicative inverse. Okay, extended Euclid's. Okay, so for this we just need 3 variables. The first one is t1, next one is t2, and the next one is t. Okay, t1 is initialized to 0 and t2 is initialized to 1. Now the formula for finding t is nothing but t is equal to t1 minus q times t2. I think you would have guessed it right. Yes, to find t we use this quotient also. So for the first iteration we'll be taking t is equal to t1 is 0, q is 3 and t2 is 1. This is minus 3. That's all. And now we'll be shifting it. So t1 will hold the value of t2. So 1 comes here, minus 3 goes here. And then we'll be calculating the new t value. So here, what is t1? T1 is 1. Minus, what is q? Q is 1. What is t2? T2 is minus 3. So 1 minus 1 into minus 3. This becomes 1 plus 3. That is 4. And now we can shift it minus 3, 4. And the t value will be, as we know, t is equal to t1 minus q times t2. The t1 value is minus 3 minus the q value for this is 2, and then the t2 value is 4, which is minus 3 minus 8, that is minus 11. And 4 comes here, minus 11 comes here, and with the same calculation we'll be getting 15 here, and minus 11 comes here, 15 comes here, and here we'll be getting something like minus 101. And now this value will be written here. This is the final answer, because the step where we arrived at GCD equals 1, that is the same step which gives the multiplicative inverse for the particular problem. So 15 is the multiplicative inverse of 27 inverse mod 101. So 27 inverse mod 101 is equal to 15. So this is how we find the multiplicative inverse. So this particular portion is very important before learning how Hill cipher works. For better understanding, let us have one other example to find the multiplicative inverse of 56 inverse mod 104. So all we have to do is use Euclid's algorithm first and check for its GCD. If the GCD is equal to 1, multiplicative inverse exists. Else, multiplicative inverse does not exist. So at first we can use Euclid's algorithm. So in Euclid's algorithm, Q, A, B and R will be written. Which is the greatest, 56 or 104? 104. So 104 is initialized to A, and then B is 56. Take your calculator, and 104 is divided by 56, and the quotient is 1. And to find the remainder, it's like minus 1 into 56, 48. Similarly, 56, 48, 56 divided by 48 is 1, and to get the remainder it is minus 1 into 48. The remainder is 8, and so on. So 48, 8, so 8 6 are 48, the remainder is 0, and here I get 8 and here I get 0. So the GCD is 8, which means the GCD is not equal to 1. Hence we could conclude that multiplicative inverse does not exist. Now we are going to perform encryption in Hill cipher. Encrypt the plain text college using Hill cipher with the key 5132. In Caesar cipher, we have used just one key in order to perform both encryption and decryption. But in Hill cipher, we are using matrix as the key in order to perform the encryption and decryption. There are certain conditions in order to select keys used for both encryption and decryption. So the conditions for selecting the key is the first one is the key should be a square matrix, which means in this case I have chosen a 2 cross 2 square matrix. So the key matrix should be a square matrix for sure. The second one is the determinant should not be 0, which means it should be non-singular. The matrix should be non-singular. The third one is the GCD of the determinant of the matrix and the mod value m should be equal to 1. So these are all the possible cases. I have already told you that the mod value m in English is 26. So these are all the possible conditions for selecting the key matrix. The formula used for encryption in Hill cipher is C is equal to K into P mod M. This is the formula used for encryption. K is nothing but the key matrix. P is nothing but the plain text matrix, which means this college is again will be represented as a matrix, and then mod M. M is 26. So for this, we know that simple rule. If I need to multiply two matrices, the column of the first matrix and the rows of the second matrix should have the same size, which means m cross n and n cross q. Only then I'll be getting a matrix with m cross q. For this, I have to formulate my plain text in such a way. So plain text is given as college, right? And my key is a 2 cross 2 matrix. So the key is a 2 cross 2 matrix, and I don't know how many rows my plain text will hold, but the key's column is 2, right? Which means the plain text's rows should also be 2. Number of rows in plain text should also be 2. So this should be something like 2 cross 3 or whatever it may be, that depends. Now I have to write this college in a 2 cross 2 matrix or in a 2 cross 3 matrix, whatever it may be. Okay, let me divide it. So C O L L E G E. I need 2 rows for sure. So I'm just dividing this into syllables like C O L L E G, and this E is alone. For this I'm just doing a padding. Like I'm just adding some X. So this is like filler, the filler value. Okay. Now we need the corresponding numerical positions for this. Let me write it like this. C is equal to, what is key? 5132 into, what is P? P, I have to list it vertically actually. C O L L E G E X. This is how it is written. Now we have to write the numerical equivalence of this particular matrix. Now the numerical position for the particular plain text matrix is written like this. Now I have to perform the normal matrix multiplication. We can just use a scientific calculator. Just go to mode, and click 2 and then shift 4. It asks for dimension, edit, matrix and so on. I have to enter the dimension, and this is for matrix 1, and this is a 2 cross 2 matrix, right? So I'm giving it as 2 2. This asks me to enter the value, so it is 5 1 3 and 2. Now click AC shift 4, and now I need to enter the matrix 2. Let me enter 1, 2, 2 rows and 3 columns. Let me feed in the first 3, which is 2, 11, 4, 14, 11 and 6. That is nothing but I'm just multiplying this particular matrix with this 2 cross 3 matrix, and then I'll be multiplying this with this 2 cross 1 matrix. So this is what I want. So now AC, again shift 4, and now go to matrix 3. I'm just selecting matrix 1 and multiplication, shift 4, again 3, matrix B. So the first value is 24, the next is 66, 26, 34, 55, 24. Yeah, so let us just write down. The values are 24, 66, 26, 34, 55 and 24. I still have one more column to fill up, right? Let me perform the same. So I have already fed in matrix 1, and now I have to pass one other matrix, and the dimension is for matrix 3. It is 2 rows with 1 column. So the values are 4 and 23. So 4 and 23. Okay, now AC shift 4, 3, matrix 1 should be multiplied with matrix 3, which is C. Matrix 3. I got 43 and 58. 43, 58. And then mod 26. Now I have to reduce each and every element present in this matrix with respect to mod 26. 24 mod 26 is 24. 66 mod 26 is 66 divided by 26. I get quotient as 2. So minus 2 into 26 is the mod value. So the remainder is 14. 26 mod 26 is 0. Similarly, we find the mod value for everything. This is 8, this is 3, this is 24 and this is 6. Now substitute the corresponding characters for these numbers. So for 24 it is Y, for 14 it is O, for 0 it is A, for 17 it is R, for 8 is I, for 3 it is D, for 24 it is again Y, and for 6 it is G. It is better to write down all the alphabets in English and just number them from 0 to 25. That would be easier. So this is nothing but Y, I, O, D, A, Y, R, G. So COLLEGE is, this is actually X, so neglect this term. College is encrypted to YIODAYR in Hill Cipher. This is how encryption is done in Hill Cipher. Now we are going to perform decryption in Hill Cipher for the ciphertext YIODAYR using the same key, where the key is 5132. The formula used for decryption is simple. This is derived from the formula that we have used for encryption. For encryption, we have used C is equal to K into P mod M. Now, we need to find the plain text. So, P is equal to, we have to just pre-multiply this with K inverse in order to get rid of K. That is nothing but, we are going to pre-multiply with K inverse. So if I just multiply K inverse and K inverse here, K and K inverse will get cancelled, right? And then P will be K inverse into C. So P is equal to K inverse into C mod M. So this is the formula used for decryption. So for this we have to find K inverse first. We know that the formula for K inverse is equal to 1 by determinant of K into adjoint of K. So for this, first we have to compute K inverse and then multiply this K inverse with the cipher text and then reduce it with modulus value. To find the determinant, I need K, where K is equal to 5, 1, 3, 2. Since it is a 2 cross 2 matrix, it is very simple to find the determinant, which is 5 into 2, 10, minus 3 into 1, 3. So the determinant is 7. Determinant of K is 7. Now let us find the adjoint of K. I'll give you a simple trick using the calculator to find the adjoint value. So first, go to mode, go to matrix, shift 4 and go to dimension, matrix A, this 2 cross 2 and feed in the values as 5, 1, 3, 2. Okay, now click AC, shift 4 and click the matrix 1 and click on X inverse and then press equal to. Now multiply with the determinant value. We found that the determinant value is 7. So now we get 2, minus 1, minus 3, 5. This is the actual adjoint value. So adjoint of K is, and what is the actual formula that is used for decryption? P is equal to K inverse into C mod M and K inverse is equal to 1 by determinant of C into adjoint of K again mod M. So this is nothing but determinant of K inverse into adjoint of K mod M, and this can again be written as determinant of K inverse mod M into adjoint of K mod M. So I have to find 7 inverse mod 26 and the adjoint is 2 minus 1 minus 3 5 mod 26. For this we use Euclids and extended Euclids, and this is not a very big task. So let's find out this first. 26 and 7. A holds the highest value as I have told you earlier. 26 divided by 7. The quotient is 3. Now minus 3 into 7. The remainder is 5. So this is 7, 5. So 5 ones are 5, remainder is 2. 5, 2. 2 twos are 4, remainder is 1. 2, 1, 1 twos, 1 twos are 2. 0, 1, 0. GCD is 1, which means multiplicative inverse exists. Now using extended Euclids, T1, T2, T, which is 0, 1. So T is equal to T1 minus Q times T2. Here it is 0 minus 3 times 1. So this is minus 3. Here it is 1 minus 3. And this is minus 3, 4, and this becomes minus 11. This is 4 minus 11, and that is 26. So I got something like minus 11. So we can't have negative values. So how do we deal with it? We know that the mod value is 26. So I simply add 26 with this, and this will give me 15. So 7 inverse mod 26 is 15. Thus we have computed this part. Now I need to just reduce this with mod 26. Now let us reduce this matrix with respect to mod 26, and for that it is 15 into 2 mod 26 is 2, minus 1 mod 26 is minus 1 mod 26, it is 1 mod 26 which is 1, and now we include this negative plus 26 which is 25. The same way minus 3 mod 26 will become 23, and this is 5. Again we need to reduce it with mod 26, but it's not necessary since the values are less than 26. Now I'll be performing the simple multiplication and mod 26. Okay, now let us just reduce it. This is the K inverse. We have just found K inverse. We still have the part P is equal to K inverse into C mod M. We need to multiply this K inverse with C. What is our C? P is equal to K is 4, 11, 7, 23, and the ciphertext C is nothing but Y I O D A Y R G mod 26. I need to substitute this with its corresponding numerical positions. So 4, 11, 7, 23, and then Y corresponds to 24, this O corresponds to 14. Now we'll be performing the normal multiplication using calculator. So the result will be like, now we'll be just reducing this with mod 26. So this will give me, so the corresponding alphabets for this numerical positions is nothing but C, O, L, L, E, G, E and X. When I rewrite this, I'll get C, O, L, L, E, G, E, X, where this X is the one which we have written as filler. So the cipher text YIODAYRG is decrypted in order to get the original plain text. This is how both encryption and decryption is done using Hill cipher.